Welcome to the channel. Today we're diving into a classic system design interview question, designing a URL shortening service like TinyURL. Buckle up as we walk through this interesting challenge step by step. Let's get started. First things first, we need to understand the problem and establish the design scope. When you're faced with a system design question in an interview, it's critical to ask clarifying questions. For example, can you give an example of how URL shortener works? In this case, your service would create a shorter alias such as tinyurl.com/jhgur4j given a long URL, and by clicking the URL, it should redirect to the original long URL. What will be the traffic volume? They'll give an answer such as 100 million URLs generated per day. How long should the URL shortened be? As short as possible. What characters are allowed in the shortened URL? In this case, an example would be A to Z, lowercase, uppercase A to Z, and 0 to 9. Can the shortened URLs be deleted or updated? No. We're going to assume no in this case. With this information, we have our basic use cases: URL shortening, URL redirecting, and considerations for high availability, scalability, and fault tolerance. Now let's do some back of the envelope estimations. We need to estimate the read and write operations and storage requirements. Here's a quick breakdown. For the write operations, assuming 100 million URLs per day, we can calculate the writes to be roughly 1100 writes per second. And assuming that the read to write ratio is 10 to 1, we can calculate roughly 11,000 reads per second. And if we want to store this information for over 10 years and assume that a single entry is roughly 100 bytes per URL, we can calculate the overall storage requirement to be roughly 365 terabytes. It is important to walk through these assumptions with your interviewer to ensure you're on the same page. Let's go ahead and propose the APIs and core entities of the system. We'll design two REST-style API endpoints, URL shortening and URL redirecting. The shortening would be a post endpoint with the request parameters being the long URL string, and the response would be the short URL. And the URL redirect would be a get endpoint with, given the short URL, it'll redirect to the long URL with either 301 or 302 redirect. The core entities in this case are just the URL, and the database access patterns are creating the URL entry and getting the long URL given the short URL. After these steps, we can go ahead and start diagramming the high-level design. So in this case, a user will make a request to create or get the URL. The request will go through the API gateway which will authenticate, rate limit, and load balance. In this case, we're not going to dive into how this is going to work. Then the request will go to a URL service, which will either create or get the URL, and that will go through the database, which has the ID, the short form URL, and the long form URL. After doing the high-level design, we can go into the deep dive. And in this case, we need to understand and design how creating the short form URL is going to work. If we have 62 characters, we need to know how short the URL will be. In this case, 7 characters will suffice because 7 characters will help us generate 365 billion URLs. There are 2 approaches that we can take among many to create this 7 character. One is by using a hash function and some collision resolution, and these hash functions can be MD5, SHA-1, CRC32, and we can do some conflict resolution using Bloom filters. The second approach is by just converting an ID to base62 representation. And in this case, I'm going to go into how to do with the second approach using base62 conversion. And that's going to work by checking to see if the long form data is in the database. And if it's not in the database, we're going to generate a unique ID. We'll have a service for that unique ID generator that will convert the ID to a short form using base62, and then we'll create a new entry in the database given the ID, the short form URL, and the long form URL. The redirect flow will work as such. The user will type in the short form URL, the load balancer will get this traffic and redirect it to web servers, and we'll check to see if the short form URL is in the cache. If not, we'll check the database and update the cache as a result. So after the deep dive, we can now have the updated system design where the request comes in, goes through the API gateway, goes to the URL service. We either create or get the long form URL. If we're creating a new short URL, we'll call the ID generator service that will return an ID. We will convert this ID to a base64, and then we'll store it in the database and the cache, and then we'll return that short form URL. If we're redirecting, the request comes in, goes to the URL service, we'll check the cache. If it's not in the cache, we'll check the database, we'll return the long form URL with a 302 redirect or 301 redirect. Let's go through an example. So let's say we want to shorten news.google.com/home and beyond. We'll call the ID generator service that will return some unique ID. We'll convert that to base62. In this case, it'll be 1VPE6RD, and we'll save that in the database, the ID, the short form URL, and the long form URL. To wrap up, we've discussed API design, the data model, the hash functions, and the flows for the URL shortening and redirecting. If there's extra time in the interview, consider discussing additional topics like rate limiting, web server scaling, database scaling, analytics, and the core concepts of availability, consistency, and reliability. That's a wrap for today's video. I hope you find this breakdown helpful. If you did, make sure you like, comment, and subscribe for more system design content. Thanks for watching, and happy coding.